In this video I will show you how to mill a part from an Alibre Design 3D model. First we start by opening our assembly that contains the part that we want to make. In this video it will be a watch case that I will later mill from titanium. We open the part in a new window and I've already done some preparations by making 4 different configurations. 2 with final shapes and 2 for machining purposes, 1 for the lathe and 1 for the mill. First we will make a 3D model for the CAM program, an STL file. So we select Export and choose File Format STL. The exported STL model is a finished case. Why we did this will become clear later in the video. After exporting our model, we can now go to the milling configuration and make a drawing of it. This is needed for the contours for the CAM program. So we make a drawing of the case. We select a blank piece of paper, A4 will be sufficient, and we make sure that our scale is 100%. So first we orient the part so that the top is facing towards us, and we deselect every view except the front side view. Then we make sure that our scale is indeed 100% and we select OK. Then we can insert the view into our drawing. Somewhere in the lower left corner will be good enough, as we can later move this around in our CAD program. When saving the drawing, I prefer to use the lowest format of DXF possible, because not every program can handle the higher formats. Now we can open our drawing in QCad, and the first thing we're going to do is flatten the drawing to get rid of any leftover 3D information from the 3D CAD program. Otherwise this will create great problems when later on trying to make polylines out of it. We then proceed by moving the drawing to the X0, Y0 position, or the origin, because that is where we want our part to be when it's on the machine. I prefer to put every visible object of the drawing on one layer, layer 0 in this case, so that what we have is on that layer and what we will add will be on another layer. I have now renamed the layer visible to the layer contour, and I changed the color to yellow to make it stand out a bit. On this layer we will construct our milling contour by selecting some parts and putting them on the contour layer and adding some other parts. I have selected the sides of the case and put them on the contour layer. I will now add some small elements just half a millimeter away from the case, because these parts are already machined down to size. We don't need to touch them with the tool again. Half a millimeter will give me all the space I need. Then I will draw some lines to sort of bridge the gap, because the lugs will be machined in a later setup. And as a last operation, I will join the lines to make a closed contour again, after removing the now redundant original contour lines. We can now save our drawing and I always choose Save As and go even lower with the format to a release 10 DXF. And of course I get all kinds of warnings, but I can ignore them. I know what I'm doing. After we have done all our preparation work, we can now open the drawing in CamBam. We put the contours on the origin, so everything is centered right where we want it. We will now first select all the elements on the contour layer and convert them to a polyline. After that, we will join all the polyline segments so we get one continuous contour for milling. And then it's time to import our 3D model into this program. So we select Draw, from Mesh File, we select our STL file and open it into the drawing. We can see that this case is not oriented properly, and it's also shifted by 3.5 millimeters. I know that because I measured it beforehand. So first we move it down 3.5 millimeters along the y-axis. And then we rotate it 90 degrees along the x-axis. Now we have the case where it will be on the machine when we put it on the machine. Let's just put it on another layer. So that it has a different color and it stands out more. I don't like the green. Let's make it gray. That one will do. So now we have our 2D contours and our 3D shape. And we will start with the first milling operation. A trochoidal profile. High-speed machining. This is a plugin that was written by one of the other users of CamBam, and it's a really nice way to machine hard materials like titanium. I always start with filling in the details of the tool, because if you want to generate the tool paths, it's immediately visible what the machine is going to do, and you can always change things afterwards. I set my depth and my depth step. My feeds, 1000 will do in titanium, and because we're going to move down just beside the material, that's why I put the 0.5 millimeter offset in, I can plunge down with 1000 millimeters a minute as well. On this corner we will set our start point so that the mill will not touch the metal when it goes down. We check our milling direction, climb milling for better surface quality, and we set an offset of 0.15 millimeters on the contour to allow for some material for finish milling. Then we generate the tool paths, and these are quite big passes. This will not work in titanium, so from 0.4 we go to 0.025, which is basically 1/10 of a millimeter step over, because we're going 11.5 millimeters deep in one go. Then we select the contour again and we pick a basic profile operation. We copy the first operation and we paste the format to the second, so that most of the parameters are already correct. We change the depth step to 2/10 of a millimeter, reduce the speed to 500, and we remove the offset of 0.15 millimeters. Where was it again? Somewhere down here. We generate our tool paths, and as we zoom in, we can see that there is a very small gap between the paths of the rough milling operation and the finish milling operation. And now we come to the cool part. Why is there a 3D model in this? Because basically only 2D contours would have been sufficient for this operation. But we can see now that there are some paths, tool paths, cutting air above the slope on the watch case. So we can lower our start plane, our work plane, and you see that it only starts now at the vertical portion of the contour. So that's no cutting air there, which saves a few minutes of time. In total this will take just over an hour because I have a very small machine and titanium is of course a very hard material. We can now generate our G-code. This always takes a while. It's some 400 Ks of G-code that we have to make. But now we're ready to go to the mill.